Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we'll explore how to get started with Amazon Managed Workflows for Apache Airflow, or Amazon MWAA. We'll begin by understanding what MWAA is and where it fits into modern data engineering and orchestration strategies. Then we'll explore how MWAA integrates with other AWS services like S3, IAM, and Amazon Redshift, and follow best practices for security, scalability, and cost efficiency. Let's get started. Before we dive into Amazon MWAA, it's important to understand the foundation it's built on. Apache Airflow. Apache Airflow is an open-source workflow orchestration platform developed at Airbnb and now maintained by the Apache Software Foundation. It's designed to help engineers and data teams programmatically author, schedule, and monitor workflows using what's called a directed acyclic graph, or DAG. These DAGs represent the flow of tasks and the dependencies between them, providing a clear and repeatable way to automate complex pipelines. One of Airflow's core strengths is that it's Python native. This means you write your workflows as Python code, giving you the full flexibility and power of the Python ecosystem. You can use control structures like loops and conditionals, pull in libraries, and dynamically generate tasks. Airflow is built around a task-based architecture, where each step in your pipeline is a discrete task. Tasks can be set up to run in parallel or sequentially based on how you define their dependencies. This makes it easy to break down large jobs into modular, manageable components. Behind the scenes, Airflow has a decoupled scheduler and executor model. The scheduler is responsible for triggering tasks at the right time, while the executor determines how and where the tasks run. This architecture enables scalability. Airflow also comes with a rich library of operators and hooks that allow you to connect with databases, cloud services, APIs, and more, making integration with systems like AWS, GCP, and on-premise data sources straightforward. And finally, a key design principle of Airflow is idempotency. This means that tasks are designed to be safely retried, which is critical in production environments where failures can and do happen. With built-in retry logic, backfills, and dependency tracking, Airflow helps ensure your workflows are both resilient and reliable. Now that we've looked at Apache Airflow, let's shift focus to Amazon MWAA, or Managed Workflows for Apache Airflow. Amazon MWAA is a fully managed service that takes the complexity out of running Apache Airflow on your own. With MWAA, you don't need to worry about provisioning servers, setting up schedulers and workers, managing Airflow updates, or ensuring high availability. Importantly, MWAA runs open-source Apache Airflow, so there's no vendor lock-in or proprietary syntax. You can bring in your existing DAGs, plugins, and Airflow configurations, and they'll run just as they would in a self-managed environment. This gives you the best of both worlds: the flexibility of open source with the convenience of managed infrastructure. One of MWAA's greatest strengths is its tight integration with AWS services. Your DAG definitions and logs are stored in Amazon S3. Authentication and access control are handled using IAM, allowing secure, fine-grained permissions. It integrates with Amazon RDS under the hood to manage the Airflow metadata database. You also get native monitoring via Amazon CloudWatch and the ability to deploy environments inside your VPC for secure network access. MWAA environments are built for scalability and high availability. The service automatically adjusts the number of Airflow workers based on your workload. Plus, it's designed to be resilient, with resources spread across multiple availability zones to reduce downtime and improve fault tolerance. MWAA is particularly well suited for orchestrating data and machine learning workflows on AWS. Whether you're building ETL pipelines, training ML models, or coordinating complex multi-step processes across services like Redshift, Glue, EMR, SageMaker, or Lambda, MWAA gives you a native and scalable orchestration layer to tie it all together. Let's take a closer look at the core components that power Amazon MWAA. A DAG, or directed acyclic graph, is the blueprint of your workflow. It defines the set of tasks and the dependencies between them in a non-circular structure. In MWAA, your DAGs are written as Python code and stored in an Amazon S3 bucket, making it easy to version, audit, and update them. Each DAG is parsed regularly by the system to determine which tasks need to run and when. Driving this execution logic is the Airflow scheduler. The scheduler is a continuously running process that scans all active DAGs, triggers runs based on schedules or external events, and queues up tasks for execution. In Amazon MWAA, this scheduler is managed for you, optimized for high availability and performance. Once tasks are scheduled, they're handed off to Airflow executors, which run them in isolated worker processes. MWAA supports executors like Celery, enabling parallel task execution across multiple workers. These workers scale automatically depending on the volume of tasks, providing elasticity without the operational burden of managing compute infrastructure. All the operational metadata behind your workflows, such as DAG versions, task states, run history, variables, and connection definitions, is stored in a metadata database. In MWAA, this is backed by a fully managed Amazon RDS for PostgreSQL instance, eliminating the need to manage your own database while ensuring consistency and durability of critical orchestration data. To extend Airflow's functionality, MWAA supports the use of custom plugins. Plugins allow you to add your own operators, sensors, hooks, macros, or even UI components. These are also stored in your S3 bucket and loaded dynamically, enabling you to build reusable, modular extensions tailored to your organization's needs. This architecture diagram highlights how Amazon Managed Workflows for Apache Airflow, or MWAA, orchestrates data workflows in a secure, scalable, and fully managed environment. At the center of this setup is the MWAA environment itself, which runs your Airflow scheduler, web server, and dynamically provisioned workers. These workers, both base and auto-scaled, execute tasks defined in your DAGs and are managed by AWS, freeing you from infrastructure overhead. Secure access to external systems and credentials is handled through AWS Secrets Manager, enabling your workflows to use sensitive configuration data like API keys and database passwords without hard-coding them. From there, MWAA interacts with a broad range of AWS services as part of workflow execution. Amazon S3 is where DAG files, plugins, and dependencies are stored. MWAA automatically pulls the latest workflow definitions and code from S3. Amazon CloudWatch provides monitoring, logging, and alerting capabilities for Airflow tasks and infrastructure health. Amazon RDS is used to store the metadata information. The entire MWAA environment operates within an Amazon VPC, providing network isolation and control over inbound and outbound traffic. VPC endpoints and private link connections ensure that all communication between Airflow workers and AWS services is secure and does not traverse the public internet. In essence, this architecture demonstrates how MWAA acts as a central orchestrator, managing task execution, data flow, and system coordination, all while providing strong security, scalability, and integration with AWS native services. The Airflow UI typically includes a DAG editor plugin or IDE extension, allowing developers to write DAG code in the browser itself. You can start with a Python scaffold, define the DAG object, add your task definitions, set dependencies, and immediately deploy it to the Airflow environment, all without ever leaving the web interface. Let's look at a sample DAG we've built in this manner using the UI. This DAG orchestrates a multi-stage data pipeline from provisioning to termination. It begins by provisioning a compute cluster, such as a Spark or EMR cluster, to handle resource-intensive operations. Next, it extracts raw data from one or more sources and loads it into a centralized location, such as S3 or a staging database. Once the data is loaded, the DAG launches several parallel pre-processing tasks, each responsible for preparing different datasets. These could involve cleaning, normalization, or feature engineering, depending on the use case. This parallelism improves efficiency and reduces total processing time. After all pre-processing tasks are complete, the DAG then decommissions the cluster, ensuring resources are cleaned up and costs are minimized. Finally, it triggers an external workflow and then monitors its progress using Airflow's sensor or API-based mechanisms. Apache Airflow uses pure Python to define directed acyclic graphs, DAGs, giving developers full programmatic control over workflow orchestration. A DAG file is simply a Python script that lives in the Airflow environment and gets parsed by the scheduler to determine what tasks to run and when. Each DAG script typically starts by importing necessary modules, including Airflow's core classes and a variety of operators, which represent individual tasks. Within the DAG definition, you specify attributes such as the schedule interval, start date, default arguments, and catch-up behavior. Tasks are declared using operators and then linked to one another to form dependencies using intuitive syntax. This expressive Pythonic approach enables the use of dynamic DAG generation, conditional branching, loops, and integration with external libraries, making Airflow highly adaptable to complex orchestration scenarios. Airflow also supports the use of macros, templating with Jinja, and custom Python functions within operators, allowing for reusable and maintainable workflow code. This illustration is the code view of the visual representation in the previous slide. The Airflow web server is the primary user interface for interacting with workflows in Amazon MWAA, offering a rich, browser-based experience for monitoring, debugging, and managing DAGs. Accessing the web server in MWAA is simple and secure. It's launched directly from the AWS Management Console, where authentication is handled through IAM, removing the burden of managing separate Airflow user credentials. This seamless integration with AWS Identity Services ensures secure access control and easier onboarding for users. Once inside the UI, you're presented with a centralized view of all active DAGs in your environment. The interface provides powerful real-time monitoring tools such as the tree view, graph view, and Gantt chart, which allow you to visually trace the flow of task execution, understand dependencies, and quickly identify where failures or delays are occurring. The Airflow UI is also highly interactive. You can manually trigger DAG runs, clear individual tasks, rerun failed operations, or pause and resume workflows directly from the interface. These controls are invaluable during development, testing, or when troubleshooting complex data pipelines in production. MWAA supports role-based access control ACK within the Airflow UI, enabling fine-grained permissions. This means that developers, data engineers, and operators can be given access appropriate to their role. For instance, allowing one group to edit DAGs while restricting others to read-only monitoring. Another key feature is access to logs. Task-level execution logs are made available within the UI and are backed by Amazon CloudWatch, making it easy to view detailed output, debug issues, and correlate events across runs, all without needing to access the underlying infrastructure. Each Amazon MWAA environment provides logical isolation, and the Airflow web server can be configured with read-only access, enabling secure visibility for auditors and stakeholders without risking unintended changes. As your workflows grow in complexity and volume, scaling and performance become critical to maintaining reliable and efficient data pipelines. Amazon MWAA offers built-in scalability, but there are several best practices you should keep in mind to make the most of it. First, the choice of executor plays a significant role. MWAA uses the Celery executor, which allows tasks to be distributed across multiple worker nodes. This supports parallel execution and is ideal for handling high-throughput environments. For even more advanced needs, self-managed Airflow deployments can leverage alternatives like the Kubernetes executor. One of the key strengths of MWAA is its automatic worker scaling. Based on the volume of queued tasks and system resource usage, MWAA dynamically scales worker instances up or down. This elasticity ensures you're only using the compute power you need. Another critical factor is how you design your DAGs and tasks. It's a best practice to keep tasks granular and modular. Instead of one long-running task, split the logic into smaller pieces. This improves task retry behavior, makes debugging easier, and enhances overall throughput by enabling parallelism. Speaking of parallelism, make sure you tune your Airflow configuration settings like parallelism, DAG concurrency, and max active tasks per DAG. These parameters control how many tasks can run concurrently across the environment and within each DAG. Under-provisioning these values can lead to backlogs, while over-provisioning may cause resource contention. It's also important to think about scheduler efficiency. Avoid placing heavy logic in the DAG definition itself. When DAGs are parsed, which happens frequently, complex Python code can slow down the scheduler. Offload configuration to environment variables or separate files when possible. Finally, minimize performance hits from Airflow variable and connection lookups. These values are stored in the metadata database, and repeated access during task execution can slow things down. Instead, retrieve them once per run and cache them locally within the task. Security and compliance are critical when orchestrating workflows that move and process sensitive or business-critical data. Amazon MWAA is designed with robust security controls that align with AWS's enterprise-grade best practices. First, all data in MWAA is encrypted, both in transit using TLS and at rest using KMS. This ensures strong protection whether data is moving between systems or being stored in S3, logs, or the metadata database. Access to MWAA and related resources is governed by fine-grained IAM policies, enabling you to tightly control who can deploy data, access logs, trigger workflows, or manage environment settings. This level of control supports strong separation of duties and aligns with least privilege access models. For managing secrets, MWAA integrates seamlessly with AWS Secrets Manager. Instead of hard-coding passwords, tokens, or keys inside your DAG files, you can reference them securely via environment variables or custom plugins, reducing the risk of credential exposure in code or logs. MWAA can also be deployed into private subnets within a VPC, giving you network-level isolation from the public internet. This allows you to safely connect to private databases, internal APIs, and on-premise resources using VPC peering or AWS Direct Connect. Additionally, each MWAA environment is logically isolated. Resources such as S3 buckets, CloudWatch logs, IAM roles, and DAG directories are scoped per environment. This prevents cross-environment access and ensures clean operational boundaries between development, staging, and production setups. To support governance and compliance needs, every API call and access event is logged in AWS CloudTrail. This enables full traceability and auditability, essential for regulated industries and organizations with strict operational oversight. Understanding the pricing model for Amazon Managed Workflows for Apache Airflow, or MWAA, is key to managing cost while scaling your data workflows effectively. MWAA pricing is composed of several dimensions. First, you're billed for the Airflow environment itself on an hourly basis. This includes the cost of the scheduler and the web server, and it accrues whether the environment is actively running tasks or completely idle. It's similar to EC2 pricing in that regard. The meter runs as long as the environment is turned on. Next, there's the cost associated with worker task execution. MWAA automatically provisions and scales workers based on your DAG's requirements, and you're charged based on vCPU seconds and GB seconds of usage during task runs. One key benefit of MWAA is that worker scaling is automatic, so you're not paying for unused capacity. When your DAGs are idle or less resource intensive, worker nodes scale down, reducing costs. In addition to compute costs, you'll incur storage charges. MWAA uses Amazon S3 to store your DAG code and Amazon CloudWatch to retain task logs. These are billed separately according to the standard S3 and CloudWatch pricing tiers, depending on your data volume and retention settings. The size of your environment, including the instance type for the scheduler and web server, and the maximum number of workers, has a direct impact on cost. You can tune these parameters to align with workload needs while staying within budget. It's also important to be mindful of data transfer costs. If your workflows interact with external systems or cross VPC boundaries, the standard AWS data transfer rates will apply. Overall, while MWAA provides a powerful and fully managed orchestration environment, cost optimization requires thoughtful sizing, efficient DAG design, and strategic use of resources. Monitoring is a critical part of maintaining healthy, reliable data pipelines, and MWAA offers several integrated and extensible ways to keep a close eye on your workflows. First, MWAA has native integration with Amazon CloudWatch, where logs from the scheduler, web server, and worker nodes are automatically pushed. This allows you to centrally view logs, set up log retention policies, and configure alerts based on log patterns or errors. The Airflow Web UI, accessible through the AWS console, remains one of the most powerful tools for real-time workflow monitoring. You can drill into DAG runs, inspect task durations, view retry behavior, and track downstream dependencies, all from a single interface. To go a level deeper, you can configure CloudWatch alarms on environment-level metrics like CPU and memory usage, task duration, and failure counts. These alarms help you proactively detect issues like bottlenecks or unexpected spikes in resource consumption, allowing you to take preemptive action before failures occur. MWAA also supports stats de-integration, which opens up advanced metrics collection. You can emit custom metrics around task success rates, queue lengths, or DAG performance. All interactions with the MWA environment, whether through the console, API, or CLI, are logged in AWS CloudTrail, providing a full audit trail for compliance and debugging. This is essential for regulated environments where tracking configuration changes is mandatory. Additionally, Airflow's built-in alerting lets you set up email or webhook notifications for task failures, retries, and SLA misses. These alerts help engineering and operations teams respond quickly to problems as they occur. And finally, for teams with mature observability stacks, MWA can be integrated with third-party monitoring tools like Datadog, Prometheus, or Grafana. These integrations enable rich visualizations, real-time dashboards, and advanced analytics beyond the native AWS interfaces. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.